Already we have covered algorithms in the previous lecture, and we will see that how the heap sort technique will work and sort the given sequence. And we will apply this algorithm on one numerical to have a feel that how it actually works. So let's start. Okay, so now we are having both algorithms written here because we have to use this algorithm to solve the numerical. This is your heap sort, the entire algorithm of heap sort, and this is your uh, building a heap. So let me write some values here which we are interested to sort. Let's say our array A is 5, 2, 9, 68. Now this sequence is not a heap. So if you make a tree 5 to 9, 60 and 8 here, you will see that this is not a heap. So the very first thing is you need to apply the heap, and this procedure will convert this sequence into a heap. So what is required? Already we have discussed this algorithm. Now what is required here? Heap size equals to length. So here the length is, heap size will be the 5. And we have to make a for loop for I equals to a length by 2 down to 1. So when you say a length is the heap size. So heap size is what? This is 5 by 2. So I will go from 5 by 2 floor value down to 1. That is from 2 to 1. Actually, we are applying this method to non-leaf nodes. So these are leaves. This is leaf, leaf, leaf. This is non-leaf node. So from the last non-leaf node to the root, we have to apply the Heapify. So from 2, this is index 2, this is index 1, 2, 3, 4, 5. So we have to apply the Heapify from to this node and then to this node. So when I equals to 2, we will find the left child. Left child equals to 2i plus 2i, and 2i is what? 2i is 2 into 2, that is 4, that is index 4. So what is a of 4? A of 4 is 60, that is the left child of this, and the right child is 2i plus 1, which is index 5, that is a of 5 is 8. And what is a of 2? A of 2 is 60. Sorry, a of 2 is 2. Already we have practiced this kind of numericals in our previous lecture. Now you have to check which of the child is largest. So here you have to compare with the child's left child and right child. When you do the operation, you will find that this left child is having the more value than the parent. So you will keep the largest equals to the left child index, that is fourth index. So you will going to swap A4 with A of I. So here I is 2, A2. So you are going to swap A4 and A2. So what you will get? You will going to get this. Now, so you get a new tree 5, 60, 2, 8 and 9. Now when you swap with this node, that means you are here and this is a leaf, so the Heapify method will not going to call again, and you move to the next iteration. So you will exit from here and you will move to next iteration. So you move to I equals to 1. So here the left child is 2i, that is 2. So you will find the index A of 2, that is 60, and the right child will be 2i plus 1, that is 3, A of 3, which is 9. So then you will again compare the parent node with its child value, and you will find that the largest is at the index 2, and you are going to swap these two values. So the situation is to this to be swapped. So what you will get? You will get 5, 60, 5, 2, 8 and 9. And when you swap with this index, Again at this position, at this index, you are going to call again Heapify. And when you call Heapify, again you will compare with the child, and what you will observe that this need to be swapped. So what you get 68, 2, 5, 9, and now this is your heap. So when you apply build max heap on the sequence, you will get this, and this will be a heap now. You can also do the same procedure using an array. So what you can do, you can start with your given sequence. Let's say this is our array 5, 2, 9, 60, and 8. And then now one thing to keep in mind, whenever we do with the array, we need to make a little change in the indexing. Here we are assuming that this is index 1, but when we work with the array, so the index start with 0. So we will use the formula to find out the left child. Left child will be 2i plus 1. So when you assume that your index starts with 0, your left child will be 2i plus 1, and your right child is 2i plus 2. Okay, so we will see as per the condition here. Heap size will be 5. So you write here heap size, but the loop will go from I will be heap size floor -1 to the first node, that is to 0, because we are assuming that our array index starts 0. So these are certain changes that you have to keep in mind when you are applying this algorithm on an array. So what you will get this is 2 minus 1 up to 0. That means your I will go from 1 to 0. That means you have to apply the Heapify only for these two values, 0 index and the first index. That is actually, if you compare here, we also applied our Heapify on these two. So when I equals to 1, I will go for 1, I will go for 0. So when I equals to 1, what you will do, you will be going to find out the left child. So the left child will be 2i plus 1, that is index 3. So a of 3 will be 9. So a of 3 is 60, and the right child will be 2i plus 2, which is index 4. So index 4 is 8. A of 4 is 8, and yeah, your parent is a of I is 1. So a of 1 is what? 2. So you will see here for this node, the left child is this, and the right child is this. Here a of 3 is 60. Okay. Now, so you will find that which is the largest index. So largest will be index 3. So you are going to swap a1 and a3. So when you swap a1 and a3, what you will get? You will get 5. Your new array will be like this: 5, 60, 9, 2, and 8. And you are here. And when you are here, you have to, this is index 3. So you have to again apply the Heapify. So when you apply the Heapify, you have to check that the left and right child exist or not. So for index 3, left child will be 2i plus 1, which is not existing. Right child will be 2i plus 2, which is also not existing. That means you will not call recursively Heapify, and then you move to the next iteration, that is for I equals to 0. So when I equals to 0, you will again find left child equals to 2i plus 1, which is index 1. Index 1 means a of 1 is 60, and right child will be 2i plus 2, that is index 2, and this value at index 2 is 9, and your value at 0 is 5. So you have to, a of 0 is 5. So you have to compare whichever child is the maximum. So you will find that this is maximum. So you are going to swap these two values. So when you swap these two values, what you will get? You will get 65, 9, 2 and 8. And after swapping, you will be here at index 1. So when you are at index 1, again the Heapify will be called. So when you call the Heapify, what you will find? You have to find out the left and right child of this index. So when I equals to 1, then the left child will be 2i plus 1, that is index 3, and the right child will be 2i plus 2, that is index 4. So you can see here this is 0, 1, 2, 3, 4. So if you look at this, this is index 3, this is index 4. So you have to compare this with this, and you will find that this is having a more value than 5. So you are going to swap this and this. So what you will get when you swap this, you will get 68, 9, 2, 5, and you are here, and here it is already a leaf, so there is no need to call Heapify, and this is the sequence which is already a heap, which is a max heap. So when you apply the build max heap, you can either do it using a tree, or you can also iterate using an array. But keep in mind, when you are doing with an array, we need to use this formula. Now this is only the first part we have covered in the heap sort. The first step is build max heap, and the next step is we need to perform these steps for n minus 1 number of times. So we will see that how it can be performed. So now let's apply the heap sort to our a sequence. Already we have applied a build max heap, and with the build max heap we get our sequence like this: 68, 9, 2, 5. So this sequence is now a max heap, but it is not a sorted sequence. So we will now apply these steps. Now here you can see that we need to make a loop from I length a to down to 1. Now here we are working on the array, so we need to make some changes here because our array index starts from 0. So let us say this is our array, which is our heap. This array is representing our heap, and the index is 0, 1, 2, 3, 4. So our heap is of size 5. Now here I will be going to be length of a down to 2. So here when we say down to 2, because in our tree when we assume this as a heap, then we start this as a 1, 2, 3, 4, 5, 6, 7, and we say that we have to do this iteration from the last node to the second last node. So we are saying from the last to index 2. But when we work with the array, then in place of assuming this 0, 1, 1, 2, 3, we need to assign this as 0, 1, 2, 3, 4, 5 and 6, and in that case we will say that we have to go from 6th index to the first index. So what we will do, we will make a iteration like heap size minus 1, because if you are having an array of size 6, then it will go from 0 to 5. So if your heap size is of 6, then the last index will be 5. So we'll say heap size minus 1 to 1. So we are just replacing this part as heap size minus 1 to 1. So what is the heap size? Heap size we have 5. So we'll say we'll make our loop from 4 to 1. Now we will do these steps for this number of times. So we'll start here when I equals to 4. So what is required when I equals to 4? Then do exchange a1. Now this is a1 is written that this represents the first element. So when we are doing with the array, so we will make it as a0. So we'll exchange the root value from the last leaf. A0 to a1 we have to swap. So this is your root, This is your last leaf, so you are going to exchange this. So we are going to have a new array. We say 5, 8, 9, 2 and 60. Then second step is heap size will be heap size minus 1. So our heap size is this 5. So heap size will be now 4. Heap size is 4. That means now we are working only on this part. This is out. This actually this means that already we have placed the one element in the correct position, and you can see that 60 is the highest element, maximum element, and we have placed at the right position. Then we have to call Maxibify A1. So when I say this algorithm, we are assuming that our index start at 1. So A1 means from the very first index. So in the case of arrays, we will change it to A0. So I'll call here Heapify. It is actually Maxibify A0. So you are going to call a Heapify here. So when your index is 0, then left child will be 2i plus 1, that is index 1. So index 1 means a of 1 is 8, and right child will be 2i plus 2, that is index 2, that is a of 2. A of 2 is what? 9. And your a0, you are calling the Heapify at index 0. So a of 0 is what? 5. Now if you look at this, we already discussed that how to apply the Heapify. So you need to compare this element with the child element. So this is the left child, is right child, and you have to exchange with the maximum value. So here you can see that this is your right child is going to be have a maximum value, so you are going to swap with this two. So when you swap these two values, this and this, so what you will get? You will get 9, 8, 5, 2. Now we know that Heapify is a recursive function. So when you are swapping with this index, now you are going to call Heapify again for this index. This index is 2. So you will find the left child and right child. So the left child of index 2 is 2i plus 1, which is if I equals to 2. In that case, your left child will be index 5, and the right child will be 2i plus 2, that is 6. And we don't have index 5 and 6, so that means there is no left and right child existing. So your iteration for I equals to 4 is finished, and then you go to next value. That means for I equals to 3. So when I equals to 3, what is required? Exchange A0 with AI. So again you will exchange. Now this is your array. Keep in mind that now our new array, or you can say our new heap, is this much. So now you have to swap the last element with the first element. So what you are doing? You are going to swap this 2, 8, 5, 9 and 60, and also you are going to reduce the heap size. So now heap size is going to reduce. So now this is your new heap. This will be not into consideration. Your heap is only this much, and your heap size is 3. Earlier it was 4. And now you are going to call Heapify at this index 0. So this is 0, index 1, 0, 1 and 2. So when you apply the Heapify at index 0, so you say Heapify A0. So you need to check your left child. Left child is 2i plus 1. So that is actually index 1. Index 1 is what? 8. And your right child is 2i plus 2, which is index 2. So a of 2 is 5, and you are calling Heapify at index 0, which is value 2. So now you have to compare with the child, and you will find that the uh, left child is having a maximum value. So if you remember the Heapify, actually we are having one variable largest that actually point that which index having a largest value. So we will say that largest equals to 1. That means index 1 is having a largest value, and we are going to swap a of 1 with a of I. So a of I means a of 0. So we are going to swap these two values. So when you swap these two values, what you will observe? You will get this scenario. You get 8, 2, 5, and this is your 60, which is not a part of this heap. Heap is only this much. Now when you swap these two values, so means you are here, and then again you have to call a Heapify. But before you call Heapify, you have to check that for this node your left and right child exist or not. So you find left child. So left child will be, you can write it here, left child when your I equals to 1, not I, when you are at this index, then what is your left child? Left child is 2I. So here I am, when I say I here, actually represent to the index. So 2I plus 1, that means uh, this is 1, so this is 3, and the right child will be 2I plus 2, that is 4. So a of 3 is what? So if you look at this, a of 3 is when a of 4 is actually not existing. So left hand exists or not, let us cross check. So we have index 1, index 0, index 1, index 2. Index 3 is also not existing. That means even for this node there is no left child, there is no right child. So we don't need to call reheapify again, and we move to the next iteration. Next iteration means now we move to I equals to 2. Now for I equals to 2, your heap size is 2. Now you have this scenario. What is required? You need to exchange the A0 with the last element. So you are going to exchange 8 and 5. So what you will get? You will get 5, 2, 8, 9, 60. And also you are going to reduce the heap size by 1. That means this is your new heap, and this is already detached from your heap. Now you need to call Heapify at this index 0. So you call Heapify A0. So you need to find out your left child. Left child is 2I plus 1, which is index 1, which is A of 1. A of 1 is 2. And right child is 2I plus 2, which is index 2. So A of 2 is equals to, so actually if you look here, we don't have right child existing, we have only left child existing. So you are going to check that your A of 0 need to be swapped or not, means are the child of A0 having a more value or not. So for A0 we don't have a right child, but we have a left child, but we observe that the left child value is already less than the parent, so there is no need to do any swapping. And this Heapify will exit here, and we go to the next iteration. So we go when I equals to, now keep in mind we have to make a loop from I equals to 4 to 1. So now we did iteration for 4, 3, 2 and 1. This is the last iteration that we are doing, and heap size will also be 1, and this heap size will be 1 when you will going to swap the last leaf from the root value. So you will swap this 2, you get 5, 8, 9 and 60, and your heap size is only 1, this one. So you are working only for this. So now you will find that uh, do we need to apply Heapify? So when you call Heapify A0, means at this index, so you will find that this is the only node left in your heap. So though we see this entire array, but actually you are working for this, so actually you are left with only this situation. We have only this scenario left. There is no left child, there is no right child. That means there is nothing to do with the Heapify, and all your iterations for I has finished, and you will stop at this point. Now what you will observe? You will observe that you get this array 2, 5, this is your actual array, 8, 9, 60, and we have seen that now this is a sorted array. So this is how the things are working. You need to first build a max heap for the given sequence, and then you will be doing n minus 1 number of times heapify operations, and when you finish this process you will get your arrays sorted as we have seen here. And keep in mind, and this will be big O of n log n effort will be required to get this sorted sequence. So I hope that you have understood that how to apply heap sort to any given sequence, and also we have discussed about its analysis, its performance. So in the next lecture we will see some more sorting algorithms. This is all for this lecture. Thank you very much.